In this video, we're going to look at the string library. Now, in order to represent a string, what we do is we put it inside double quotes. So you can see here the string hello is inside the double quotes. Now, the reason for doing this is that the assembler, whenever it sees the double quotes, it knows what's inside as a string. And then it converts that string to an ASCII code. So the ASCII code is American Standard Code for Information Interchange. So that just means that it's going to take, for example, the letter H and it's going to represent it by a number, and then the letter E and represent it by a different number. It's so we can get the string values into the computer. Now, there's one other thing it does whenever it represents a string. So in memory, it will place the H, the ASCII code for H in memory, and then the ASCII code for E, L, L, and O in memory. But we need to know when we have actually hit the end of a string. So what we do is, at the very end, we put in a special character, and we can call that special character a string delimiter. Now, the reason for doing this is that if we didn't do it, we wouldn't know whether the next value in memory after the O was actually an ASCII character or not. And if we put the string delimiter in, we know for sure where the last ASCII character is held in memory. And if we didn't have that, then we could continue along, and we would convert the next value and the value after that into ASCII when it isn't an ASCII character, it's something else. Now, you'll see that whenever we work through a simple example. So that's all we need to know about the string representation. So we want to work out the string length. We can push the string onto the stack. We can push the position for the length onto the stack as well, and then we can jump to the subroutine. It'll work out the string length. In this instance, the string length is going to be 5 for the 5 characters, and it will return that value 5 into the memory location length. So pretty straightforward. Now, the next one we're going to look at is the string concatenation. So by concatenation, we mean we join them together. So if you had the string H, and you can notice there's actually a space here, so there's H and then a space, and then you're going to have the other string, which is the letter E. Then we're going to concatenate it, so whenever it's finished, we should have the H space E. Now we push string 1, we push string 2, and then we push string 3, which is where we're going to store the result. We jump to the subroutine and it concatenates them. But remember, whenever it's concatenated, what it's going to come out with in memory, you're going to have the ASCII for H, and then the ASCII for space, and then the ASCII for E, and then you're going to have the string delimiter. Now, the final one we're going to look at here is the string copy. So we just want to take a copy of the string and place it in a different memory location. So we're going to have our hello with the string delimiter, and we're going to take it and take all of that information and then post it somewhere else in memory. So we've got the string here, hello, and we're going to have the string copy. And you'll notice here that I've set a limit on the string copy. So it will copy anything up to 256 characters. Of course, we could change this and make it larger than that if we wanted to. I just picked a kind of arbitrary figure for this for the moment. And we're going to push the string onto the stack, the position of the copy onto the stack as well, and we get into the subroutine, and it just copies it over to these other memory locations, and that's the end of it. So that's all we have for the string library. If we want, we can expand and extend on this, and we could generate other subroutines. And I probably will do some more in the future. Now we'll pick one of these to work through, and I think maybe we'll do the string concatenation, and we'll see that working now. So I've loaded the program in. Let's simulate it. Now let's check and make sure it's running at full speed. Okay. It shouldn't take that long, just several seconds or so in order for it to load everything in and jump through the concatenation. And you can see that's us finished. So let's save this or stop it, and we'll drop in and we will have a look and see what's happened within memory. Now we could, if we wanted to, take these values and use the string print in order to print them to the screen. But I didn't want to overcomplicate the description here, so I'll just show you within the actual memory here. So we're going to have within memory the letter H, which in ASCII is going to be the 0048. Okay, so this is ASCII in effect in hex. And then the space is 0020. And then I mentioned that we're going to have a string delimiter. So there's the string delimiter here. It's all zeros. So that's the first string. Now the second string is going to be the value of E. So E is the number 65 in our ASCII. So that's 65's hex. And then we have the string delimiter, which is the value of 0. And then we're going to join them together. So to join them together, we're going to have the 48 and the 20 and then the 65. So it becomes H space E. So there we have H is 48, the space is the 20, E is the 65. And in fact, the next one here is the 0000 is the string delimiter. So that's it worked, and that's how we generate our ASCII and how we place our ASCII within our memory location. So that's it for the string values. As I said, we could probably generate a few more commands, and I may well do that in the future. The next thing we want to be able to do is represent fractional numbers, and we're going to do that using a fixed point system. And this is quite fun because it will allow us to generate some cool mathematical functions. So thank you for listening. I'll get you on the next video. Goodbye.